Hi everyone, this video is going to be about gravitational potential energy and kinetic energy. It is a video that's going to go along with this assignment here. So first of all, gravitational potential energy, you should have reviewed that in one of the earlier lessons with types of energy. It's the energy that objects have when they're off the ground, and we calculate it using this equation here. E for energy, we do a little p for potential, and then it's mass times gravity times by the height of the object off the ground. Okay, so let's have a look at an example. So here is an apple in a tree. The apple is off the ground, so therefore it has gravitational potential energy, but how much? How much energy it has depends on its mass and on the height it is off the ground. The higher it is, the more energy, or the bigger the mass, the more energy. So let's have a look. The apple is 0.15 kgs. And the apple is 2 meters off the ground. That's all the information we need. Potential energy equals mass times gravity times height. Remember, gravity is always 10, so we simply go 0.15 times by 10 times by 2 meters off the ground, and it equals 3 joules. Okay, so we're just plugging in numbers like we have with any other equation. Let's look at another example. We're going to skip across to the right-hand side here to this one here, the sliding. So Sarah has a mass of 64 kgs. How much potential energy will she have at the top of a 3.5 meter high slide? Well, her mass, 64, gravity is always 10, and the height is 3.5. So we go 64 times 10 times 3.5. She has 2,240 joules of energy at the top of the slide. Now here is an important question. What energy transformations will happen as she travels down the slide? Well, as she goes down the slide, her height will decrease, so she's going to lose gravitational potential energy. Okay, that's going to decrease, and it's going to be transformed into other forms. What is it? The gravitational potential energy, first and foremost, is going to be changed into kinetic. Kinetic energy being the energy that moving things have. So she's going to increase her speed as she goes down the slide, so her kinetic energy is going to increase. There's also going to be a bit of heat. If you've ever been on one of those metal slides and it kind of sticks to you, it can get a bit hot if you go down fast because of friction, and sound energy. There might be a little bit of rustling kind of sound. So that relationship, that transformation of energy from gravitational to kinetic is important, and we'll discuss it briefly later. Okay, so moving down, I want to have a look at Roger Federer. So in this particular example, Roger Federer, who's a famous tennis player, hits a tennis ball directly up into the air, so straight up. The mass of the tennis ball is 60 grams, so we're going to have to convert that to kgs. And he hits the ball 45 meters high. And in this question, we're going to look to calculate gravitational potential energy. So here is the answer here. Gravitational potential energy is equal to mass times gravity times height. The mass, because it was 60 grams, we need to convert that into kgs, which is that, times by 10 for gravity, times by the height, 45. So the ball has 27 joules of energy when it's right at the top of where it's been hit. So all the way up at 45 meters. Okay, so now we're going to have a look at kinetic energy. So kinetic energy is the energy that moving things have. And here's the formula. Energy, with a little k to represent kinetic energy, equals a half, so you can just do that 0.5, times by the mass, times by the velocity or the speed, squared. That's really important, that squared part. Lots of students forget that. So let's have a look at an example of that. So we're going to look at this top question here. Calculate the kinetic energy of an 800 kg van traveling at 4 meters per second. So the formula here is a half times by the mass, which is 800, times by the speed, squared. So when we type that in our calculator, it's really important. We go 0.5 times by 800 times by 4 squared. Okay, the answer is 64 joules. That can't be right. 6,400 joules, sorry. And so, again, same as the previous equation, we're just inputting our numbers, substituting our numbers there. We're going to leave the rest of that question. So in the assignment, there'll be a couple of questions for you to do where you're just plugging in numbers. Okay. The final part of this, which is the excellence part of this sort of concept, is the conservation of energy. So gravitational potential energy is the energy that objects have when they're off the ground. So if we think of Roger Federer's tennis ball, it had 27 joules of potential energy at the top up here. So as it went up, he hit it down on the ground here. As it went up, it increased its gravitational potential energy. The higher and higher and higher it went, until it reached its maximum height. Then it had its maximum gravitational potential energy. Now you guys will know what happens when a ball or anything starts falling to the ground, is it starts to speed up. So up here, essentially at this little instant, it's not moving at all. Just for that tiny split second, it goes up and stops and then starts moving down. So as it starts moving down, it increases its speed. As it increases its speed, it's going to increase its kinetic energy. If I flick back to here, if the speed is bigger, then the kinetic energy is going to be higher. So as the ball's falling, it's getting faster and faster and faster, so its kinetic energy is increasing. Now that is the opposite of what's happening to the potential energy. The potential energy was the maximum up here, but as it gets closer and closer and closer to the ground, the height is less, so therefore its potential energy decreases. So the maximum potential energy that it had up here is going to be equal to the maximum kinetic energy down here. Okay, they are opposites of each other. Okay, as the potential energy increases, the kinetic energy is going to decrease, and as the kinetic energy increases, the gravitational potential energy is going to decrease. With one exception, is that in real life, the exact number of potential energy, so in this example here, this question here. So let's have a look at this. So Roger Federer, when he hit the ball up in the air, it had 27 joules of energy right at the top of the top of the hit. But then its kinetic energy was only 19 joules when it was down the bottom. So I've been telling you that this maximum potential energy should equal the maximum kinetic energy. But in real life, it doesn't. Usually, the kinetic energy is a little bit less. And the question is why? And the answer is pretty simple, is that some of the potential energy has been transformed into other types of energy. For instance, heat through friction as it's going through the air, maybe a little bit of sound. Okay, so some energy is kind of lost to those other types of energy. But the general principle is that the maximum potential energy is going to equal the maximum kinetic energy, except there will be a little bit of lost energy to heat and sound. Okay, so on the assignment, there are the formula at the top, some pages for you to read in SciPad, that's very brief, and then some pages in the SciPad to answer, that's just to practice those little calculations, and then there are 2 exam questions. Okay, don't forget to ask for questions on our live meet at 9:30 to 10:30 or 2:30 to 3:30. Thanks everyone, bye.